Hello and welcome to Noel's Retro Lab. Today, you guessed it, we're gonna take care of Commodore number 3 in our triple Commodore 64 repair challenge. It was supposed to be all in one video, but it turns out the other two were a lot more complicated than I expected, so we ended up releasing one video for each of them. So today, hopefully, we'll be able to diagnose and fix this one, and maybe it will be a lot easier than the other ones, who knows? So let's open it up and find out. So as usual, let's start having a look at the board. Right away, we notice that this is a slightly later version than the other boards we looked at. And one of the things it has is the much more simplified clock generation circuitry. Thank you. Also, we don't have the metal shield around here. That's nice, makes working on the VIC a lot easier. And everything looks very good, very clean. Nothing obviously changed. The back also looks really good. So, okay, let's measure voltages. Okay, let's start checking 5 volts at the LED. And again, maybe that's a little on the low side. Maybe we do have a similar short as we did last time, but okay, at least we get power there. Let's check the 2 voltage regulators. Input, yep, and output should be 5, yep. And here the input was higher, was it like 19? Yeah, and output should be 12. Yeah, perfect. So those are good. And while we're here, let's check the power to the VIC chip, which comes directly from those 2 regulators, but we might as well. So pin 40 is 5 volts, yep. And pin 13 is 12. And yep, so this is powered correctly. Moving to the other side of the board, we should have 5 volts right here. Yeah, I mean, we definitely, it's definitely on the low side. And we should have 9 AC, or 9.5 there. Almost 10, okay, yeah. That's good. So voltages seem a little low, but they seem fine mostly across the board. So one thing worth noticing about this board, especially if you've seen the last 2 videos that I've done about repairing Commodore 64s, is that the layout is a little different. It's not just the clock generation circuitry that is different, but over here, this may look like it's a socketed PLA, but it's not. This is the SID. This is the PLA. They've actually changed those 2 places. So you always have to rely either on the numbering themselves, which are a little confusing since they're both MOS and they're both the same size and everything, but you can always rely on the numbering on the board. So U17 is the PLA and U18 is the SID. So keep that in mind to avoid any confusions when you're looking at different revisions of the board. Let's start as usual by looking at the clock signal going into the VIC chip. So that's pin 22. And yeah, that's perfect. 7.8 megahertz. Good. Let's look now directly at the CPU, which is pin 1. Yep, about 1 megahertz signal, and the clock out of the CPU. That one also looks good. Okay, so clock signals look fine. Let's check the sync and color out of the VIC. For 14 and 15, that seems about right for a blank screen, and that's also fine. Okay, so it looks like it's sending an okay signal, it's just blank. So next thing, let's look at some of the lines around the CPU, starting with the reset line. We've learned our lesson from the first one, and that's high, good. Let's see if there's activity, so let's look at ready and IRQ. Okay, nothing there, and nothing there. Read-write, it's a 38. Read-write, there is nothing. Okay, this is starting to look suspiciously like last time. Let's look at the address bus. 6 should be 5 volts. Yeah, that's fine. Even that's a little low. And then address bus. Okay, at least we have activity on the address bus. Yeah, that's fine. I'm going to jump ahead on the address bus. The last few bits, often, like here maybe. Yeah, this happens again. The last few bits get flat. There's nothing. Yep. Yeah, this is very similar to last time. And then the data bus, 30 through 37, so we can start from 37. Ooh, that looks bad. It looks like there's some fighting there. That's probably our short right there. 36 also looks really bad. 35, they all look really bad. Yeah, the data bus looks horrible. That at least we're getting mostly regular voltages. They're just some weird, if we do a single capture, it's not even going to 0. Yeah, not looking good, any of it. Okay. So now that this has been on for a few minutes, let's check to see if something gets particularly hot. If it gets hot, but that's pretty normal. PLA is normal. CPU, maybe a little hot, but within reason. SID usually gets pretty hot. Yeah. Well, it's pretty warm for a ROM. Oh, 40 something. And again, the kernel ROM, which is exactly what was wrong last time. Interesting. So the ROMs look pretty warm, especially that one. That combined with the low voltage and the 5 volt rail makes me think we have a short there. Yeah, I think it's definitely good to replace this one. So on this side, they're still kind of stuck with solder. So I'm going to resolder them with fresh solder and then desolder them again. That usually frees them up and makes it so we can remove the chip much more easily. With the ROM desoldered and removed from the board, let's measure voltages again. Let's do it directly here. See if we get something closer to 5. 4.68. That's better, but it's still not great. It feels like there's something else also shorted. But since there was nothing else that was really hot, I mean, some of the other ROMs were a little hot. What we should do now is try turning on the board with a dead test cartridge and see what happens. Okay, let's turn it on and see what happens. Okay, we get some signal at least. That went away. But we're still not getting the actual test image. Okay. Oh. Okay, the screen flashed white when I turned it off. One thing I've seen is that sometimes if you turn on and off the switch multiple times, and you get white flashes, it's a sign that the PLA might be faulty. So let me try turning it on and off a few times. Yeah. Yeah, so that's one more indication that the PLA could be at fault here. So I think the best thing to do now is to remove that and test it on a different board, and then we can also measure voltages, see if they get closer to 5 volts. Here we have our trusty working board. You've seen it plenty of times already if you watch the other videos. And we have the PLA, the suspect PLA here. Notice that it's in a different location, so you have to go by U17, which, yeah, it says right there on this board. So anyway, it's in, Let's turn it on and see what happens. Okay, we get some signal and we get no video. I don't have the test cartridge in right now, so I was just expecting to see the basic prompt. So that means the PLA is definitely faulty. So far we have a very similar problem to the previous board. The kernel ROM seems to be faulty, and so is the PLA. Will that be everything? I don't know. Let's try it. Let's pop in the working PLA on the other board and see if we can get the cartridge tests to work. All right, this is the board that we're working on with the PLA that we know it works. So before we even try it with a test, I want to see if the voltage is any different now. Well, is it enough to get us closer to 5? And 4.73, so yeah, I mean, every time we change one of those, it gets better. It's still not perfect. There could be something else shorted, potentially one of those ROMs. But if it's a ROM and if it's not catastrophically bad, we should be able to get the test to work right now. Let's see it. Okay, test cartridge is in. Let's see what happens. We get some kind of signal, enough to get a black screen, and we don't seem to get anything yet for the test screen that we would expect. So maybe one of those is wrong. So really what I should do now is look at signals again, see if they look any better around the CPU. Oh wait, we get something. We get a purple screen. I actually hadn't seen that before. I should look it up in the manual for the dead test cartridge to see if that means anything. I'm going to turn it off and turn it on again. Usually a solid color screen, I think it means bad PLA, but we know the PLA is fine. So it could be something else related to the PLA. Let's see. And it took a long time to show up too, so that was a little odd. Okay, so it comes up right away with a purple screen. Interesting. I dug up the documentation for the dead test cartridge, and there's no mention of anything like a purple screen or even like a solid color screen. Supposedly, the test starts, if it detects some kind of memory problem, it will flash the border, and if not, we should see the test screen. So this tells me that it's doing something unexpected and maybe the data bus is clobbered. Okay, let's check some of the signals around the CPU again. We can start with the out clock from the CPU, that's fine. Read write. Okay, so this one was a flat line before. We're definitely making some progress. Now the CPU is working, it's trying to read and write from memory. And then here start the address bus, no, the data bus, sorry, and that looks totally wrong. That looks, again, like a short. It looks cleaner than before, but it looks like somebody is shorted to ground and is trying to put a signal in there. That, it's weird, it doesn't even go to 0. Yeah, they're like kind of floating in there. That looks horrible. Okay, so we definitely still have some kind of a short. I'm suspecting one of the ROMs is going to be the problem. We know it's not the PLA. I should remove the SID just in case. Although the SID has access to the data bus, so I should probably try that right now. Okay, SID is gone. Turn this on, and let's see if it makes any difference. This is read write. And this is the data bus. Oh, looks better. Definitely looks better. What's our voltage now? What are we up to? We're up to 4.85. So maybe the SID had a problem. It's definitely worth trying with the diagnostic tests. All right, once again, we have the dead test cartridge, and we've removed the SID in addition to that ROM that was getting really hot, the kernel ROM, and the different PLA. Turn it on, we get some kind of signal. And, oh, there we go. We get the test. So the SID was shorting out the data bus, and it was preventing the system from starting up even with the cartridge test, because the data that it was trying to read from the test was coming on the data bus, and it was just getting shorted to 0. So this is what we had to pull out. The SID, the PLA, and the ROM. That's an expensive repair, unfortunately. Those two chips are not cheap to come by. The ROM, as we saw before, we can definitely make an adapter for it and get it working pretty easily with an EEPROM, but those are they're not impossible, but they're a little bit more difficult to get. So I put in a new SID chip and a new ROM chip that I had around, and let's see if we can get it started with the basic prompt. There we go. Perfect. We have another working Commodore 64. So just to make sure, we've definitely determined that the PLA and the SID are faulty, for sure. But the ROM, we don't know that for sure. I mean, it was hot, it was the first thing I removed, and the voltage improved, but it's not like I popped it in somewhere else to test it. So what I've done is I put a SID that definitely works, and I socketed the spot and put the ROM back in place. And let's see if we can start it out. If not, then we'll definitely be replacing. Oh, there we go. So it turns out we didn't have to replace this ROM, and the hot temperature, the 40-some degrees, apparently is kind of normal, and that might explain why in the previous computer we actually had to replace it, because if they get so hot, those are the chips that eventually end up developing problems. So, okay, that's a little better. The only two things that we had to replace on this board was the PLA and the SID, and now we have a working Commodore 64. Excellent. So I hope you enjoyed this video and in general the Commodore 64 repair series. I hope it was useful and you can apply it to repairing some of your own Commodore 64s. If you liked it, please give it a thumbs up and consider subscribing to the channel. There will be many more videos coming up with Commodores and other retro systems as well as electronics in general. Until next video, see you next time.